We're checking in with Kraken Pinion 8680, a team that we've been covering for a long time here in First Updates Now. You can go back and check some of the interviews that we've done with them. Building fantastic robots every year, and I'm sure this in a robot 30 hours is going to be no exception. So let's check on in. Kraken Pinion, if you don't mind, introduce yourself, talk about your team a little bit, and let's jump right into your robot then.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
First Updates Now is supported by Kettering University. Kettering University is where robotics students come for their education. Over 30% of those who attend Kettering University were in high school robotics, and you can keep going with their BattleBots, VexU, esports, and FIRST mentorship programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12, 2021.
My name is Mikey Florsheim, and Kraken Pinion has been around for around 4 or 5 years. And I think our main goal is just to leave no stone unturned and just find the best avenue to succeed in whatever game Strong has.
Well, let's talk about that a little bit. Finding success in Freight Frenzy here. Talk to us a little about some of that strategy and concept breakdowns on how you approach this robot, and of course, we'll then jump into the robot as well.
So our goal for this game in 30 hours was success within our means of accomplishing a robot in 30 hours. So I think our biggest asset in that strategy was rapid prototyping. Even though it's only been around 25 hours, we've gone through, the basket alone has gone through 4 iterations, the lift has gone through at least 3, and many more parts of the robot have been iterated many, many times in this short period of time.
So let's jump into the robot. Talk to me. Let's start breaking down some of the systems. Now, an interesting thing, if you watch the interview we did with the other team, Rising Rhinos, they were talking about how Mechanum wasn't working out well for them, but you have Mechanum on your drive base here, so talk to me a little bit more about that.
Yeah, so what we did is we made our drivetrain only 12 inches wide, and we used Mechanum wheels so that we're able to fit through the gaps at the edge of the rails in the field wall, so that we don't have to traverse over the rails, which we found because we would have problems with using our odometry dead wheels if we had to cross over the rails. So we wanted to figure out a way to be able to get past them without having to go over them.
Yeah, that's a really interesting thing you bring up because talking about odometry, many people are saying odometry is useless this year, right, with the obstacles. But if you were able to build a robot that fits within the constraints of the field, is that the main reason you went with that size of a robot, or were there some other areas you're looking at too?
Another one we thought of was speed, because we can get our gear ratio is really high with this. We can go really fast. And just agility around the field, because Mechanum wheels allow us to move around so easily that we can just get wherever we need to be on the field really quickly.
So talk to me a little bit. Let's go into some of the other components that are on your robot. Whichever one you want to start with first, go ahead and talk to me about some of the concept to it, and then if you've done any testing with it as well, how it's been working out for you.
All right. So the first part we'll be going over is the intake. We saw a lot of ties between this game and Robotics, which we had a lot of success in. So we kind of got our inspiration of our intake in the manner in which we intake the same spheres and cubes that were in Robotics from that bot, and we kind of replicated it onto this robot in order to create better intake and lessen the research time.
All right, so let's start to walk through on this intake here. A little hard to see on camera, so where does it go exactly in the robot? Can you show off a little bit more about that?
Sure. So it's a little hard to see, but so this intake goes through the front of the robot, which leads into a ramp. And so this ramp leads into, it's a pass-through design. So that ramp leads into, we have a basket that we designed to fit in our smaller channel because it's only a 12-inch wide robot. So we had to make everything slimmer, which meant very high tolerances or low tolerances. in order to make sure everything fit correctly and ran smoothly.
Can we turn the robot around? Can we see actually where that is in that? Okay, so now you got one of the pieces inside your robot. Where's the journey going from it next?
So next, the freight, it goes into this little basket that we designed, and then it goes on this, which is attached to this bar that has a pivot. So no matter how it's pivoted, it's held in such a way that the freight cannot fall out. And then once we're at the desired height, it'll stop. And when we want it to, we can trigger this little servo to pull the door open and drop the piece of freight. And then we can drop it into wherever we want to put it.
So you can score at any level then based on that, right?
That's correct.
Okay. And then looking at that in general, when we talked to the other team that we had on as well, they talked about kind of that gravity type stage on there. So talk to me about your concept on that. Why did you decide to go that route?
Again, we went that route through the philosophy of engineering within our means. We knew we could have stabilized it with a servo and an IMU, but we decided not to because of the time constraints and how long the software would take to get perfect.
You bring up a really good point for something. What are some other things, if you had maybe like an extra week or something like that, that you would take with this robot and try to perfect a bit more?
All right, so what we have here is this here is our capstone piece, and then we have this arm, which would be attached to that over there. And so essentially that arm would grab, it's like a claw mechanism. We 3D printed these pieces, and it can deliver the capstone, put it on top of the goal. So right now it's not really working, but with more time, we will be able to finish that.
A question I posed to the other team that I was just on before as well too is what are lessons learned that you've had so far about this game, not just from Robot in 30 Hours, but something that your team will be taking into the season that you might have for advice for other teams as well.
Something big that we learned is that since different pieces of freight weigh different amounts, you have to really make sure that your intake can reliably intake them of all weights, or not failing to intake the heavier weight ones, or launching the lighter weight ones with so much force that it can cause damage or fly out of the robot.
That's a really interesting point. I think we will see some teams that struggle with that throughout the season because they just didn't do all the right due diligence to make that happen. Is there anything else on your robot that you want to highlight or show off at all?
All right, so for the carousel part of the game, we have a motor mounted with a compliant wheel on it. I think this is going to be the normal that most of the teams are going to be using. The robot just drives up to it, the wheel turns, it turns the carousel, and knocks the rubber duck off into the field. It's a solid strategy. I don't see why anyone would do anything else.
Awesome. Well, Kraken Pinion, thank you so much once again for taking the time to show off your robot in 30 hours. Still got a couple hours left, so can't wait to see potentially what comes out of that. By the way, if you want to check out what the Wisconsin Robot in 30 Hour teams are doing, we do have a link in chat, so make sure you check out their channel as well to learn a bit more about what's going on with the rest of their Robot in 30 Hours build. So good luck, of course, the rest of the way throughout this build and throughout the season as well. Thanks for taking the time.
Thanks to Kettering University for their support of this video. Don't just sit in class. Kettering University is the only school in the US that allows you to work as an engineer your first year with their 3-month on, 3-month off co-op programs. If you are a US student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021. Thank you to AndyMark, GoBuilda, and Rev Robotics for providing components and giveaways to the Bulldogs Robot in 30 Hours team. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow, join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.